What's up everyone? We're doing relations and functions, domain and range today. Two learning intentions: identify the differences and similarities of relations and functions, and identify domains and range and how the domain impacts the range. So checking out relations first up. Relation is any set of ordered pairs or coordinates, and relations can be expressed in different ways, and you've seen these all through maths. Today we're just giving them a name. So relation A, this guy's a relation. We've got some ordered pairs, x and y coordinates sitting in here. We can express it in a different way though. B, x comma y, where y is equal to 2 times x. That's going to look something like, I don't know, on this set of coordinates over here, 2 times x is maybe something like that. And we've got a different guy here, y, c, which is equal to all the x and y coordinates, where y is greater than or equal to 2x. So that would be all of these things over this side of that ordered pairs. Another example would be class names and height. So we introduce this guy over here. We've got the heights as the x coordinate, the y as the name. Sorry, height is x, name is y. Our heights are these guys. Our y's are these guys. So one ordered pair would be 1.64 and G, or Gary. So just write G there, and that would be just one of them. We'd also need to put in 1.58 and H. I'm not going to do that now though, you get the idea. I'm not going to do the rest of them. And then we use these squiggly brackets to close it off. I always sucked at drawing those squiggly brackets, but hopefully you can master the art. Domain and range. We've looked at these maybe a little bit. The domain is the set of x values of the ordered pair, while the range is a set of y values of the ordered pairs. That means the domain, for example number 1, domain is -1, 4, and 8. -1, 4, and 8, whereas the range is 5, 3, and -6. 5, 3, and -6. 2 and 3 have domain R and range R. What is R? Let's go back to, where is it, this guy. Yeah, it looks familiar. R is this dude down here. He's got all of the real numbers. Alright, so any real number can be plugged in there and we can find the domain and the range. And what about our example 4? Well, our domain will be all the heights. So the D is going to be equal to 1.64. etc. 1.58, and so it goes. Our range is going to be equal to Gary, Harry, Eliza, Tanika, Trish, and Oscar. Ghetto. Functions. A function is a type of relation, a neat relation, because being neat is fun. What do you mean neat? Well, where every x value, it's a relation where every x value is paired to a unique y value. A unique y value. That means only one y value. The way I like to think about relations and functions is like this. These guys are relations. Everything inside this circle is a relation, but the guys inside this circle are functions. Fun guys, right? So functions are a type of relation, but relations are not types of functions. And we can restrict the domain so the relation might become a function. Our height and name example over here is not a function because we've got 158 and 158 over here. But what we might want to do is restrict the domain so that we can turn that into a relation. So we could restrict the x values or the height values and say that we want to restrict all the x values and take away anything under 1.65, which means that the domain, the range rather, would be left with Gary's out, Harry's out, Eliza is in, Eliza's in, Tanika's in, and Oscar's in. Etio or Toe or Oat. I don't know. Right, so we've restricted the domain. We restricted the domain and that changed the range. Alright, as we restricted the domain, to having it anything less than 165 out, we change the range. That's what we're talking about here. How the domain and range, and how the domain impacts the range. Right? The domain shortened the range. So how do we know whether it's a function or it's a relation? There's got to be an easier way to work out this than whether or not every x value is paired to a unique y value. That doesn't make a lot of sense. What does that mean graphically? Isn't there another way of finding out whether there is something as a function or a relation? Yes, it's called a vertical line test. Draw a vertical line. If it goes through an x coordinate more than once, it is not a function, only a relation. Sad face. Right? So, in example A here, our example A, we've got 1, 2, 3 coordinates, 3 ordered pairs. Is it a vertical line test? Well, let's draw some vertical lines and test. Check it out. Here, the vertical line, that's going to be y, that vertical line is y is equal to -2. It only cuts an x coordinate once, at 4. All good. How about it, y is equal to 1? It cuts an x coordinate once. If y is equal to 3, it cuts the x coordinate and only cuts one x coordinate. That's good news. If there was an x coordinate here at 1, then this would not be a function, but it is a function otherwise. Function. This guy, we could draw any vertical line we want along here. That's not vertical. You get the idea. Vertical line there, only one x coordinate, only cuts the graph once. Every time I cut this down, these vertical lines down, I'm only cutting along this line once. So it is a function. This guy is a function. And then this dude here, this last guy, if I draw a vertical line, I'm going to have more than one cut, because I'm going to have a cut here, but this guy is also inclusive of this, and this, and this, and all the little points in between of that. So this guy is not going to be a function, right? Because we could say, is the point 1, 1 in the shaded region? Yes. Is the point 1, -1 in the shaded region? Yes. So there are 2 x coordinates, and they've got a non-unique pair. So it's not a relation. It is not a function. It is only a relation. So some examples. You got to state the domain and range of the following, and state whether it's a function or not. I should say they're a function or not. Question 1. For question 1, you got to state domain and range. Domain and range. To do that, in this example, because there's a graph, you just go read off graph. Read off graph. All right. So we can see that the x values seem to start at -1 and end at 3. So the x values for our domain is, I should use a blue pen. Doesn't really matter too much, I guess. Domain will be equal to -1, 3. Now what we can do is use these brackets instead of having to write -1, -2, -3, and -1.111 and -2. And all the numbers in between -1 and 3, and there are a lot of them. We can use these brackets here, which means that it's everything between -1 and 3, including -1 and including 3. Square brackets mean including. If it was a round bracket, it would mean not including -1 and 3. Range. Let's have a look again. In my mind, that is going from -2 to 2. So again, we can use this notation where we go square bracket -2 to 2, and that means everything in between -2 to 2. 2. The second thing we've got to think is whether or not it's a function, right? So is this guy a function? Function question mark. And what we can do to work that out is the vertical line test, right? We're thinking whether or not there is, for each y value, is there more than one x value. And so if we go back up to this guy, we draw a vertical line, it's going to cut this graph once here, twice here, and because it cuts more than once, it is not a function. And so what I would do to express that is not to write not a function, because it fails the VLT, vertical line test. Question 2. A little bit different. What this means is that you've got all these sets of coordinates, all the x and y coordinates, where y is equal to 4, take 4 minus x to the power of 3. So in our heads we need to think about what 4 minus x to the power of 3 looks like. And if we can do that in our head, fantastic. Just a brief idea of what it looks like. looks like. And for me, in my brain, I'm drawing a little graph here. X to the power of 3 normally looks like this, but this is negative x to the power of 3, so it looks like this, and then it's up 4, so it's going to look like something like this. Alright, we only need a rough sketch in our head for the domain and range, for the sake of stating the domain and range. So this purple line is what I'm sort of thinking about. It's the sort of image I've built in my head, and I'm going to write the domain is going to go from negative infinity to positive infinity, and so that means that it is the real values. Domain is real. The real values, or just are. Range, positive infinity to negative infinity. It's going to do the exact same thing, so the range will also be real. Is it a function or not? Again, we have to draw this picture in our head and then do the vertical line in our head. Right? If it helps, grab out your calculator, graph that bad boy, and see how you end up. But if we were to do the vertical line test at all different parts along here, we would eventually find out that it's not going to cut the graph more than once. Alright, if we're thinking about this purple line. Whoops. Each time that I draw a vertical line, I'm only cutting this purple thing once. So it is not a function. Sorry, it is not a relation. It is just, man, it is a function. I'm sorry, it is a function. Because it passes the vertical line test. It is a function because it passes the VLT. Alright, so what about definitions? We're going to need to use a couple of those today. So first up, I want you to take a look at, I'm not going to write them down, I'm just going to highlight them, and you're going to need to do that. So relation is our first definition word, and the definition of relation is here. A relation is any set of ordered pairs or coordinates. You might even want to say that they can be expressed in different ways, up to you. Functions is the next one I want you to take down. Right, so functions is the next one. A function is a type of relation. Here is the definition. A type of relation, skip that fun bit, where the x value is paired to a unique y value. Unique means only one. Other words we need to define is vertical line test. The vertical line test I will define down the bottom because there's not a very good definition there. Domain and range. Domain, don't want to turn these damn sticky keys. Domain is a set of x values of the ordered pair. Set of x values of the ordered pair. The range is a set of y values. So this is range. That guy is domain. Now let's go down the bottom and find a definition for the vertical line test. And here's our vertical line test definition. You can read that, write it down. If it cuts through more than one x coordinate, it is not a function. It is not a function if there's more than one x coordinate. Alright, peace out. Catch you later.